Welcome to This Explainer. Look, if you've been anywhere near the internet lately, you've absolutely heard the massive, breathless hype surrounding AI scaling and this fast approaching singularity. We are constantly being told that artificial intelligence is on this unstoppable exponential curve, right? Like it's just poised to recursively self-improve until it completely transforms our entire world overnight. But what is the actual science telling us right now? Well, today we're going to strip away all that wild speculation and look strictly at the latest empirical evidence from 2023 through 2025 to see where the physical and structural limits of AI truly lie. Okay, let's dive into this. We're going to trace a really structured journey today. We'll start with part 1, the AI explosion, then look at part 2, the rules of scaling. From there, we'll hit part 3, hitting the data wall, explore part 4, the inference era, examine part 5, the evaluation crisis, and finally, part 6, rethinking the singularity. So let's kick things off with section 1, the AI explosion, tracing the exponential curve, and see exactly how we got here in the first place. Because, to really understand the hype, we have to appreciate the history. For decades, AI progress was incredibly foundational, but honestly, it was pretty slow. Way back in 1943, we saw the conceptualization of the artificial neuron. 1950 brought us the famous Turing test, which set a benchmark for machine intelligence. Then we jump all the way to 1997 for long short-term memory, or LSTM networks, which finally gave models a robust memory mechanism for sequential data. But then, the 2010s hit, and absolutely everything accelerated. 2012 gave us AlexNet, a massive breakthrough in image classification. And then, 2017 fundamentally changed the game with the transformer architecture, that famous attention is all you need paper, which unified how AI processes sequences and literally paved the way for everything we see today. And man, that transformer architecture triggered a relentless cadence of releases. GPT-1 dropped in June 2018. Just months later, in February 2019, we got GPT-2. By June 2020, GPT-3 arrived, massively scaling up capabilities. And then GPT-4 in March 2023. These constantly shrinking gaps between major model releases gave birth to this widespread perception of an unstoppable, runaway intelligence explosion. It really felt like every few months, the models were just magically getting smarter. But actually, it wasn't magic. It's time for section 2, the rules of scaling. What drives the progress? So we can look at the underlying mechanics of all this. During this massive boom, we entered the era of foundation models. But there is a huge misconception we really need to clear up right away. A foundation model is not a finished out-of-the-box general intelligence. As the research notes, it is large-scale infrastructure pre-trained on broad data. In the real world, having broad competence absolutely doesn't equal dependable utility. To be actually useful to us, these models require an entire socio-technical stack, stuff like instruction tuning, retrieval-augmented generation, safety filters, and tool APIs. They are adaptable infrastructure, not just some autonomous brain in a jar. Now, what's really interesting here is the massive divergence between lab training and real-world capability. In the lab, researchers use what they call scaling laws to predict how throwing more compute at a model smoothly decreases its error rate, or its perplexity, which is essentially just a measure of how confused the model is. You get this beautiful, smooth curve. But the downstream task capability in the real world? It's completely jagged, it's messy, it moves in these weird step-like jumps and hits incredibly long plateaus. The research makes it very clear, just because a model is less confused on a lab chart doesn't guarantee it's actually going to reason better when you give it a complex multi-step problem. Which brings us to a pretty sobering reality check. Section 3, hitting the data wall, running out of human text. We are literally encountering our first major physical constraints to infinite scaling. See, the whole assumption behind those scaling laws is that you always have access to sufficiently diverse high-signal data. But high-quality human text is finite, and we are rapidly running out of it. Forecasting analyses show that as we exhaust the stock of human text, this literal data wall we're hitting, models are increasingly forced to train on the very outputs generated by older AI models. And this creates a highly dangerous recursive feedback loop. When 2026-era models are trained on 2024-era model outputs, we risk what researchers are calling model autophagy, or self-consuming training. The risks here are severe. First, variance collapses, meaning the AI loses its diversity of thought and just repeats generic answers. Second, errors get heavily amplified in an echo chamber. Outputs become totally homogenized, and rare but super important data modes just simply disappear. You can't just replace human data with synthetic data without risking some serious degenerative dynamics.
So to bypass this data wall, the entire industry is pivoting. Welcome to Section 4, the inference era, the new paradigm.
Before 2023, the whole frontier was about training time scaling. You built a bigger model, threw immense compute at the training phase, and you got a fixed output. But by 2025, the frontier completely shifted to inference time scaling. This means spending way more compute at the exact moment the AI generates the answer. We're talking about getting the model time for heavy deliberation, generating internal reasoning chains, and actually using external tools to verify its own work before it even speaks to you. But here is the catch. Yes, giving models more time to think at inference can improve accuracy on certain complex tasks. But thinking longer does absolutely not cure hallucinations. In fact, longer reasoning traces can actually amplify persuasion over truth. The model generates a highly detailed, incredibly coherent explanation that is completely grounded in false premises. It's a brand new failure mode. Errors that are so much harder for us to detect simply because the AI sounds incredibly convincing. Which raises a huge question. If models are becoming better at persuading us, how do we even measure their real capabilities anymore? That takes us to Section 5, the evaluation crisis, when benchmarks break. The AI industry is currently facing a severe credibility crisis when it comes to testing, and it all really comes down to Goodhart's law. When a measure becomes a target, it completely ceases to be a good measure. Because AI leaderboards dictate prestige, funding, and stock prices, developers optimize directly for those tests. Just look at the benchmark lifecycle that's happening right now. A benchmark is released, it gets adopted on a public leaderboard, the incentives to optimize kick into overdrive, and suddenly, the test data leaks straight into the training sets. Public benchmarks are now behaving like short-lived, contaminated public goods. When researchers test these top models on clean, uncontaminated versions of the tests, their scores drop significantly. A lot of these headline gains often just reflect memorized question patterns, not true, robust intelligence. And this evaluation crisis directly impacts you and me every single day. As synthetic AI-generated text and media absolutely flood the web, it severely erodes our baseline trust in digital content. If you can't easily distinguish authentic sources from automated fabrications, you just start discounting digital text altogether. This raises the verification burden massively for schools, media, and public agencies, demanding heavy investments in provenance tools and watermarking just to restore a basic level of trust. So, with all these constraints piling up, where does this leave all those grand predictions? Let's bring this home in Section 6, Rethinking the Singularity, a grounded reality check. First, we really must clearly define what we mean by the singularity in a technical sense. We are talking specifically about the recursive self-improvement, or RSI variant. This is the sci-fi scenario where an AI system becomes so smart, it can essentially write the code for its own successor, creating a runaway feedback loop of intelligence that just leaves humanity entirely in the dust. So, the crucial point is that this runaway loop is currently blocked by massive real-world friction. Building AI isn't just about generating code syntax. The first friction point is software engineering bottlenecks. Architecting systems, verifying safety, and maintaining them is a massive socio-technical task that AI absolutely cannot yet do autonomously. Second, the evaluation crisis means an AI can't reliably test if its self-improvements are actually even working. Third, that trust collapse we just talked about severely limits how these systems integrate into human society. And finally, the ultimate physical limit, the thermodynamic wall. Because guys, you cannot code your way out of physics. The thermodynamic wall dictates that compute scales with watts, cooling, and actual land. AI models can iterate in software cycles that take just months, but building new power grids, substations, and transmission lines, that takes years of linear human construction, permitting, and massive supply chain management. Yet, the singularity narrative remains incredibly powerful because it acts as this massive coordination mechanism. It's a crazy feedback loop. The hype drives massive capital commitments, literally hundreds of billions of dollars for data centers and compute clusters. But eventually, those massive financial investments violently collide with hard physical constraints, like the electrical grid capacity and the exhaustion of human data. This inevitably leads to market volatility and a very forceful reset of expectations. Which leaves us with this final, provocative thought. We are so often sold a story of an unstoppable, autonomous digital future. But if exponential digital intelligence is entirely dependent on linear, earth-bound human infrastructure, like laying concrete and stringing power lines, who really controls the speed of the singularity? The machines or us? It's definitely something to think about as you navigate all the hype.
Thank you so much for joining me for this explainer, and keep questioning the curve.